Thank you, Carl and Gabriel, for sharing your thoughts about the operations and monetization relative to 5G and providing some additional context as we continue slicing and dicing today's topic. So now we've heard market insights from analysts, and we've gotten CTO perspectives from Verizon and Ericsson. But now it's time to get MEF's position on 5G and end-to-end network slicing. For that, MEF CTO Pascal Menezes joins us once again to talk about why end-to-end slicing is so critical for the network transformation, especially when coupled with 5G, edge computing, and distributed clouds. Pascal, over to you.
Hello, everyone, and welcome to today's episode on 5G. What an incredible area of innovation. I was really happy and privileged to be with two great CTOs from Ericsson and from Verizon, and that was a really great session. So today I'm going to cover what is MEF working on in 5G, and specifically around end-to-end slicing. So let me just get right to it. As you know, MEF has been working really in 4 strategic pillars around our MEF 3.0 framework. Number 1 has been this very high-speed underlay that's interconnected not on the data plane that we've been doing for the last 15 years, but also enabling the commercial business systems to be federated and connected at the automation API layer to turn up that underlay connection anywhere from any part of the globe to any other part of the globe in near real-time speeds, almost cloud-like speeds. Additionally, we've been working on that overlay layer, that SD-WAN layer. That's a really critical area that has application awareness, centralized policy, agile, and so on. So as you saw in our SD-WAN episode, it was really, really great set of information use cases. We've also been working on managed cybersecurity. And this is really working on SASE, zero trust, application protection. In our last episode or our previous one, we talked about all about great areas of SASE innovation and how managed cybersecurity is so critical. In our last episode, we talked about the edge. The edge is a very incredible area, nascent, lots of things happening, and specifically with the edge comes into 5G. So let me get right in the details of what are we seeing in 5G and why is that so important? As you know, more and more enterprises are moving into the digital transformation era as they digitize their applications, transform their applications, modernize the workflow by machines and automation to a digital workflow. With all of this comes the need for basically having these robots and these sensors and all these different types of digital kinds of devices to be able to communicate to clouds, and whether the cloud is right there at the edge. For example, robots need AI, ML inference right at that site edge, and they need a neural network right there to do the arm movements. And you might have sensors that are in industrial factory sensors that are mission critical. When something goes off, you need something to process that right away. So a large amount of telemetry data is flowing consistently, and you need some kind of analytics right there at the edge to really make heads and tails of what's important, what's not. So all these very digital transformation use cases is driving the edge at that site, and the low latency requirements of 5 milliseconds or less means that that processing has to be done right at that site. Or if it can tolerate 25 milliseconds or more, then the next processing area of that edge is going to be at the network edge, which is at some given city and so on. And then further out is the regional edge, way out in some region of a continent. So these different edges have different requirements for performance guarantees and so on, based on the use case of what is the digital workflow and the transformation trying to be achieved. So now let's talk about where slicing plays a very important role of this. Slicing is really part of the 5G technology realm, and slicing is really about enabling a kind of an airtime fairness. It is actually enabling airtime fairness and a prioritization based upon specific use cases or what the device needs that's attached. Now, with that, obviously, devices have to have an interface card that is 5G to begin with and has to be able to understand how to attach to a slice, but that's a given in the 5G technology era. But at the end of the day, what network slicing is trying to do is give this idea of a virtualized topology, a virtualized instance of the network to a subscriber that they can use in any way. And that network slice has a set of performance objectives, guarantees, and so on. And as you'll see later on in this session, we'll cover them in more detail. Now, the most important thing is that the network itself is abstracted away and delivered to a subscriber as a slice, and we call it a slice as a service. The subscriber buys that slice, which has various sites connected to it. That slice then delivers a performance guarantee, and then that slice can be used for various kinds of digital transformation use cases. So let me get into the detail of what we are trying to achieve with all of this. And it all comes down to the idea of end-to-end guarantees or end-to-end experience. As you know, most enterprises want an experience from their device, wherever they are, to wherever they want to go to. And mainly it could be the nearest site edge, which has compute. It could be the network edge that has compute, or a regional edge that has compute, or a cloud provider of some sort, some partner, or various kinds of private clouds, public clouds, and so on. Regardless where that service endpoint lives, wherever the user or device is, to wherever they have to go, they want a frictionless experience that guarantees that performance, that the application behaves right, and there's some kind of security guarantee on that. So that's a very important use case. And what slicing plays in this is part of this, is it delivers part of that objective. It complements with SD-WAN and other technologies the ability to deliver an end-to-end guarantee, a frictionless experience that enables a device or a user or an application to get a great experience to wherever it's trying to go. Now, let's get into one of the really great use cases emerging with slicing is private 5G. Now, why is private 5G so important? Well, let me talk about this in more detail. Private 5G is emerging and moving into the enterprise at rapid speeds because Wi-Fi really doesn't deliver, today's Wi-Fi doesn't deliver really that guaranteed, that mission critical performance requirements of packet loss, jitter, delay, and bandwidth guarantees, because in essence, wireless is a shared medium. It's contention-based, it's shared. And whether that be 5G or even Wi-Fi, they are shared. They're sharing a spectrum of bandwidth. And with that, there has to be this prioritization of air fairness, as I talked about. So what private 5G delivers much more elegantly than Wi-Fi is delivering that air fairness prioritization through this technology we call slicing. So a set of slices are defined in the enterprises, 5G is rolled out, and basically either a robot or an IoT sensor or a business user or various types of other kinds of digital use cases will attach to that slice, grab, and then on that slice, the performance guarantees is being specified and is guaranteed to be delivered. And then that slice goes further. It goes into the wide area network and into other areas where that flow of that very specific service has to be accommodated. Now, this is where we get to end-to-end slicing. Normally, if everything just terminated and all of the services terminated right in the building, then the private 5G and the slice in the enterprise or that environment in the factory or the warehouse would serve its purpose. But lots of times, flows might have to go beyond the edge compute of that building and has to go to services in maybe the network edge or the regional edge. And that flows then have to traverse and still maintain a performance guarantee. This is where end-to-end slicing comes in. And I'm going to talk in details about how end-to-end slicing plays a very critical role, because what happens there is from the enterprise, the slice is defined with its performance objectives and so on. And then basically from there, that slice can continue across the wide area fronts into the nearest network edge. And if there's has to terminate in services there, fine. Or maybe the slice continues further into the regional edge, into private data centers, private clouds, and public clouds and partners of all sorts. And really the goal is, can that performance guarantee of that slice keep going to wherever the service endpoints are? Now, in reality, that is going to take a while for the ecosystem to enable an end-to-end slice everywhere. So with that, also SD-WAN plays a very critical role. SD-WAN delivers the ability to create an overlay layer on top of this kind of underlay layer as we know it, but now the end-to-end slice looks like an underlay, but it's a virtual underlay. It's an abstracted underlay that it knows it has a certain performance guarantee for that slice, so that SD-WAN, which is very application aware, can place tunnels on top of these slices and say, for this given slice, I'm going to utilize this slice because I know the performance guarantee, and put application flows onto that end-to-end slice. And if the application is not mission critical, maybe offload it right then and there at that site and right onto the internet. So it doesn't use this very costly end-to-end slice that is being used for performance guaranteed versus using the internet. So these are some of the scenarios where end-to-end slicing plays a very, very important role, and how SD-WAN layers on top of it. So I don't believe SD-WAN is going to go away, but think of really end-to-end slicing as a new modern approach of how subscribers buy a service, a transport service. They don't think of it being MPLS or carry Ethernet or 5G, or they just buy a slice. And in that slice has a performance objective, it has a topology of where it's going to be delivered to, and it also has all kinds of other potentially security guarantees in the future. So this is the goal. And then again, SD-WAN can utilize that end-to-end slice, which is abstracted, and place its application flows on top. Now, you can think of an end-to-end slice as very much what we have seen in the modernization of what Windows did with hardware, or many, many operating systems did with hardware. Instead of worrying about different device types plugging in to the computer and have to program the interrupts and DMA and all that in the past and put the drivers in, today we just plug in a device, it automatically detects that, and it's all done to this hardware abstraction layer. So really what end-to-end slicing is trying to do is the same thing, regardless of where the slice starts at the enterprise or ends up some core or some public cloud, it doesn't matter. That underlay is all automated and orchestrated to deliver that end-to-end slice through automation and machine APIs. And what the customer sees is just this end-to-end slice, and not all of the underlay technology of transports to make that happen. Now, another important area that is used is that end-to-end slice is actually working with other providers to deliver this whole ecosystem of interconnection. And how that is done is basically what we're working on, is to add to Sonata, our inter-provider automation APIs, the ability to now send out and negotiate payloads, product payloads that have to do with not just carry Ethernet IP and MPLS kind of services, but now end-to-end slice product payloads. So therefore, inter-provider automation can be achieved because within one provider's domain that supports slice and slice objectives, those slices and end-to-end slices can be now negotiated and propagated to other partners in the ecosystem through that automation with Sonata APIs. So what we get is a full set of interconnected, federated providers that support these set of slice profiles, these end-to-end slice profiles that can be used and guaranteed their performance objectives. So with that, end-to-end slicing and slicing as a whole will continue to evolve. There'll be tremendous innovation in this area. And I'm proud to say that MEF has been a key leader in many, many areas of network transformation, including SD-WAN, SASE, Zero Trust, and now we're leading the way into end-to-end slicing with a lot of great work in our end-to-end slice service profile definitions, our end-to-end slice framework called MEF-84. And I hope you join us in our work, and we're doing some great innovation. And with that, I want to thank you for your time and have a great day.